All right. Well, good morning, good afternoon, everyone, and thank you for joining today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. If this is your first time tuning in, we are all about bringing science, adventure, exploration, and conservation live into classrooms across North America and beyond. So if you head over to exploringbytheseat.com, you can find anywhere from 40, 50, even 60 live events a month for classrooms to join into. And we're just getting ready to announce our December events. So some of those are actually already up on the website. So today's kind of a cool event. Today we are going to hang out with Tom Matthews, and we have been looking at weather this month as well as our theme of conservation. So we're partnered with a great group called Hearts in the Ice. Hilda Strom and Sunniva Sorby, they are overwintering in Svalbard. So they've just arrived at the remote trapper's cabin in Bumsaboo, and we're going to be doing events with them on different themes like climate change, technology, polar bears, and such. And this month, our theme is weather. So actually I have a tiny little clip I want to share. They just sent me a cool little video clip yesterday. They've just arrived at the trapper's cabin and they sent a little video clip here.
Hi everybody. Hello. We arrived Bumsaboo 4 days ago. We're outside now to preparing for another storm coming in. It's -2 today. A year ago it was like -20, and we are expecting a lot of snow the coming 24 hours, and then it's going to rain like crazy. What's happening with the climate, Sunniva?
Totally different from last year. So we have a solar panel over here, courtesy of Power Controls. And we have back here that you can't see a windmill that's generating electricity for us, or power. And we have a Round Tails mission link, which is providing satellite data connectivity courtesy of Marlink. So we're able to call all of you in a couple of days. We're all set up.
See you.
All right, so they are 140 kilometers from their nearest neighbor. In fact, polar bears are probably their nearest neighbor. And we're actually connecting with them. We're going to try via satellite link at noon with an explorer. His name's George Krunis, and he chases extreme weather and documents it around the world. All right, so today's event, pretty exciting. We've got Tom Matthews joining us. Tom is a climate scientist and a lecturer in climate science at Loughborough University in the United Kingdom. His particular interest is in the sensitivity of Earth systems to climate variability and change. Tom also took part in National Geographic and Rolex's Perpetual Planet Extreme expedition to Mount Everest. There, he helped establish the world's highest weather station. He joined a team of international scientists, storytellers, climbers on a 2-month expedition to research the effects of climate change on the glaciers in this incredible mountain environment. So I'm going to bring Tom in live with us here. Hey, Tom, how you doing today?
Hi, Joe. I'm good, thanks. How are you?
Good, good. Well, it's so good to have you joining us live today. We had you join us for an event months ago, and it was a ton of fun. Today, we've got a great group of classrooms joining us from across North America. And after we dive into your expedition a little bit, they are going to fire away with some questions.
That sounds good, Joe.
All right. Very cool. Okay, Tom. Well, when you're ready, you can take over. I'll pop the screen share in, and then, yeah, we're away.
Okay. Great. I'll start sharing my screen. Thanks, Joe. Okay, hopefully you can see my screen.
Looks good.
Great. So I really enjoyed that introduction, Joe. It was great to see the explorers up there in northern Norway or Svalbard talking about extreme weather. And hopefully what I'll talk about now continues that theme of extreme weather. And it's really also great to sort of virtually meet all of you guys out there in the classrooms. And hopefully, you know, you'll learn something from this, and hopefully you've got some questions too. You know, it's really fun to talk about extreme weather in a place where it really matters. So we'll get on to extreme weather in a moment, the why it matters bit, and why, you know, we should all care a little bit. Is because the high mountains they're really important. They store a huge amount of ice. So you're seeing a big glacier coming down from Everest here. Everest is that big black mountain that you can see towards the right of your screen. Just on the peak, it's just under the O in the word on. And there's a glacier, a river of ice flowing down from that that's hundreds and hundreds of feet thick, carries an enormous amount of water with it. And there are hundreds, thousands of glaciers like this across the surface of the Earth. And their water is really important for people living downstream. So we really do need to know what's going on with the weather up there, how climate's changing the weather, and how that in turn is changing the amount of snow and ice that's up there to supply water to people downstream. Okay, so let's kick off then. Well, to begin with, where am I? You'll notice I sound a bit different. I'm in England, in a place called Loughborough. So quite a long way from many of you, I suspect, almost as far away as the explorers in Svalbard there. So I'm about 3,500 miles away from New York, sitting in my university building in Loughborough right now. And it's just gone 3:30 in the evening. And the sun is going to set in about 10-15 minutes. So we have really short days this time of year because we're quite far north too. Svalbard is just a little bit further north and a little bit further east. Now we're going to go to Everest today. Where's Everest? Well, it's even further away. You can just see the UK in the top left of the image. So that's Loughborough, we were looking at in the previous slide. And now we're going to turn our attention to Mount Everest. This is a long way from the US. It's about 7,500 miles from New York. Home to the world's highest mountain, the Himalayas. And that highest mountain is Mount Everest. And as Joe introduced, or Joe said in his introduction, there was a big team of scientists that travelled to Everest into the spring of 2019 as part of this National Geographic and Rolex Perpetual Planet expedition to Everest. A huge scientific expedition, really ambitious, trying to understand what's going on in the region. How is it responding to climate change? And obviously that's a big question because we just outlined or understood why that area is important, because it stores an enormous amount of water. So we really do need to understand how it's changed in the past in relation to past climate change, and to also understand what the current climate's like, so we can better understand what changes may be ahead. So on the screen in front of you, you see base camp at Everest. All those yellow dots are tents, and it's home to hundreds of climbers that are going to attempt to climb Everest. Climbers, support staff, so cooks, porters, carrying all the stuff in, as well as the elite climbing Sherpa who are going to help carry things up the mountain and help get the climbers safely up the mountain. So all those yellow dots are tents. And just for reference, by the way, we're in Nepal at this point. We're on the southern side of Mount Everest. So when I click, you're going to see footage from a drone. This is taken from a drone. We're flying over base camp. And this is in the spring of 2019 to give you a sense of where we are. And look out for people moving around. You can see people walking. You get a sense of life at base camp. And I should have also pointed out the really quirky thing about this camp is it's on the ice. It's on the glacier. If you look carefully, you see that dark stuff. That's what you call debris, I suppose, mud to all intents and purposes. Underneath that, though, you can see the ice. So everyone's camping on ice, and that ice is slowly moving. So you're camping on a surface that's slowly sliding downhill, and that ice is tens, if not hundreds of feet thick there. So let's enjoy flying over it as we arrive into base camp. And spot the people walking, carrying loads, and have a good look at those tents. And you really get a sense of the ice here, of living on the ice. See how uneven the surface is. The surface melts throughout the period that you're camping on it for. You have to keep moving your bed inside your tent. Everest is up to our right at this point. So that's us arriving into base camp. And myself, as a climate scientist, along with Baker Parry from Appalachian State University in North Carolina, we were tasked with setting up weather stations to help understand what the climate is currently like in the Everest region. One thing that you may know about Everest already is that it's quite an exciting and dynamic place. Dynamic in the sense that there's lots of snow and ice and there's a lot of things going on. So avalanches are commonly seen. Really impressive, but also pretty frightening because avalanches can be dangerous. And to give you a sense of that danger and the proximity of it and the power of the landscape, play a very short clip here of a video taken from the base camp tent. So this is really close to home. and you hear this avalanche coming down across the glacier. And I mean, that avalanche, it's fascinating, but they are very dangerous. Unfortunately, they have claimed, or tragically claimed, lives before on Everest. What it reflects here is the movement of snow. It's a very natural process for redistributing snow around the landscape. The glaciers are fed by those avalanches. So that's the environment, very dynamic, a bit frightening, pretty dangerous, fascinating to observe. What's the weather like? Well, we're installing these weather stations. This is what a weather station looks like. So this is the base camp weather station. All those tents we were just looking at, you can see towards the bottom or the left-hand side of the image. You just make out those yellow dots in the corner. They're the base camp tents. So we're just a little bit down glacier now with this weather station. So just to describe a few things on there, we've got a wind sensor. That's the thing with the propellers facing towards us. That thing, I don't know if you can see my cursor, but all those metal slats hanging downwards in a circular array, that's a precipitation gauge. That measures how much snow and rain is falling. It catches it and it weighs it. The cylinders with the slats in that you can see attached to the masts, they are air temperature sensors. And they also measure how much water is in the atmosphere, so temperature and humidity. We also have sensors here. I don't know if you can see them, but those white sensors, one has a glass dome on top, the other one has a black layer on top, or black sensor on top. They're measuring solar radiation, so sunshine, and also the amount of what we call long wave radiation, so two types of radiation. We're measuring everything we need here to understand how the glaciers may respond to warming. And interestingly, we also have a camera pointing at Everest. It's on the right-hand mast, you can see there. It doesn't look much like a camera. It looks like a little cylinder with its back to us, pointing up in the direction of Everest. So we're taking pictures there of Everest twice a day. And here's today's image of the summit. So you can see the date in the top of the image there. 24th of the 11th, that's the way we do dates in the UK. We do we do day of the month, then year. Pretty cold day at base camp, -2 degrees Celsius. So about 29 Fahrenheit, I think that is. Pretty dry. And we can see a lovely clear day on Everest. Very nice. But just a few days ago on the 16th, it was a big storm on Everest. Really strong winds higher up. Lots of rain lower down and some snow up here too. So some really wild weather. And we spotted this in the pictures and had a look at the data coming from weather stations that were higher up. And I can tell you from the story that I'll tell you about the weather stations installed up there in a minute, it's quite likely there were hurricane force winds blowing over the summit of Everest on this day. So it'd be really not a good day to be up there on the summit. This is normally a time of year when people are trying to climb. This year, not because of the pandemic, but this is normally a time that's popular for the mountaineers. So this is what a bad weather day looks like on Everest from base camp. Very different from that day. So in 2019, we wanted to know about those upper slopes, what was going on higher on the mountain in terms of the weather. And the only way to answer that question is to go up the mountain, to climb up there and put the sensors in place. So you see us here climbing through the Khumbu icefall. So that glacier that you saw, that I pointed out coming down from Everest, has a really rough and uneven section called the icefall, where the ice is moving really quickly and breaking into blocks. And you have to climb through that as soon as you leave base camp. It's the first sort of barrier in your way to go higher up the mountain. And you climb at night. You climb at night because it's thought to be a bit safer then, less likely to be hit by avalanches. So you can see here a picture of one of our climbing guides. This is Daoyangsam Sherpa, a female international mountain guide who was really important in making sure we get up and down the mountain safely. It's me climbing another ladder. So ladders are a common feature of the Khumbu icefall. This is a ladder laying down as we're going over a crevasse. And this is why you move quickly, because the glacier is literally crumbling in places. It goes through the icefall. You don't want to get in the way of one of these blocks. You have to try and move quickly to get up there to put the weather stations in. But unfortunately, there could be some pretty big queues on the mountain because not everyone is there doing science. The industry, a lot of local economy is supported by climbing the world's highest mountain, so it's a very popular place in the climbing season. So what you see here is a queue of people in the icefall waiting for a ladder. Ladders were popular, and waiting for them isn't fun because you're worried that the ice is going to move in a way that's dangerous for you. So a block's going to break off or there's going to be an avalanche. But going back to the weather. So when you get up there, as you climb higher, what's it like? Well, it gets colder. The air gets colder. It always does as you go higher up in the atmosphere. So that's why snow sits on the top of mountains and not in the valley bottoms typically. But as you climb higher on Everest, that's me climbing around 7,000 meters there, so around 22,000 feet on the left. You can see the sun is beating down. And I can tell you the sun makes it feel really warm up there. Even though the air temperature is low, the sun heats you up and that makes you really warm. And some people have actually collapsed from heat exhaustion at this sort of altitude on Everest on a sunny day. If you get into the afternoon, you get far too hot if you're having to climb in the afternoon and the sun's out. Especially if you're wearing the sorts of things you see us wearing in this image. So this is Mario Patocchi of the University of Maine taking the world's highest ice core. He's drilling out a section of ice from a glacier at almost 8,000 meters, it's about 26,000 feet. And look at what everyone's wearing. So they're wearing these down suits that are filled with feathers, just like the feathers that keep Canada geese warm and other high latitude birds. That down is pushed inside the suit. It traps the heat, keeps you really nice and warm when you need to be warm. Unfortunately, it also makes you very hot when the sun comes out, and it's difficult to stay the right temperature. So I think it's nice to look at this picture to get an idea or to really appreciate how, I suppose, alien the environment is and the weather is, that we have to dress like this to keep ourselves safe. So big gloves, big suits filled with feathers to keep us warm, just like the duvet perhaps that you may have on the bed during the winter. We're walking around in those. So what's the weather like up there though when we get really high? So we put these weather stations in to find out. So we're looking at weather station here on the right hand side at a place called the South Col on the Nepalese side of Everest. It's the highest camp, the last place that you camp at on the way to Everest summit. So I don't know if you know that, but maybe I should point that out. You don't climb Everest all in one go. You don't get up in the morning and put your backpack on and say, right, I'm off, I'll see you tomorrow, climb to the summit and come back the same day. It takes you many days. So you'll stay typically at least 2 camps or 3 camps on the way up actually. You'll skip camp 1 when you're going to the summit, go camp 2, camp 3 and camp 4, and then try and go to the summit. And this is the height of camp 4. So you can see on the left-hand side, our fantastic Sherpa team who really made all this possible, helping to install the weather stations. We're attaching it to the rocks, drilling it in so the wind doesn't blow it away. And on the right-hand side, that's what the weather station looks like when it's finished. So tied down to the rocks, measuring again the wind speed, the temperature, the humidity, how much sunshine is coming in, humidity, and also the air pressure. So we're measuring all the really important bits of the weather that will be important in helping us understand how climate change is affecting this part of the world. So what does it show? What is the weather like up there? Well, we've now got some data. Spring 2019 is now quite a while ago. So we can look at the data we've collected in that period. I can tell you a little bit about what the weather's like up there. So the oxygen level we get from the air pressure. We can work out how much oxygen there is in the atmosphere by measuring that. And the average air pressure up there means it's about 37% of the oxygen that's available at sea level. So not much. You try doing exercise, walking uphill, when you've only got 37% of the sea level oxygen to work with. It's difficult. So that's why we breathe supplemental oxygen up there. The image you see here is a Baker Parry in the tent at Camp 4, breathing that supplemental oxygen. And it makes things quite a bit easier. It's still not easy. It's the equivalent of lowering yourself by about 6,000 feet in the atmosphere. So it gives you more oxygen, but still not sea level oxygen. Lowest temperature we've recorded up there so far is minus 40 Celsius, which is also minus 40 Fahrenheit. That's where Celsius and Fahrenheit meet. The highest temperature we've recorded. It's in the middle of the summer when the monsoon is affecting the region. And that was minus 1.5 degrees Celsius, about 29 degrees Fahrenheit. So the air temperature never goes above freezing. Fastest wind we've recorded up there so far was 66 meters per second, which is 150 miles per hour. So very strong indeed. We think the winds went much higher than that, but the wind sensors didn't survive. They're no longer reporting values. So the strong winds that set the record also ended the transmission life of the wind sensors. They may still be working up there, but we're not getting sensible data from them. We then went a bit higher, up to the balcony. This is the world's highest weather station. It's the only one that's ever been put in above 8,000 meters. And once you go above 8,000 meters, so around 27,000 feet, there's so little oxygen, around 34% of sea level oxygen, that it's really hard to do things. And it's quite dangerous to stay up there for a long period of time. So that's why there hasn't been a weather station put up there before. So we put this one in, 8,430 meters. That's it being installed on the left, and that's me with my hand on the cross arm that you see with the same sensors, so the wind sensors at least, and the temperature and humidity sensor there. And we're also measuring air pressure. And where's the summit from here? Well, the picture on the right-hand side that you can see is from the weather station looking at the summit. So that sort of ridge that disappears into the cloud, that's the summit ridge. So that's where this is relative to the summit. And the temperature we've seen up here so far is lower than the South Pole, which we would expect because it's higher. So we look at minus 45 degrees Celsius as the coldest we've measured so far, which is minus 49 degrees Fahrenheit. Highest temperature, minus 2.5. So we're still obviously not getting close to the freezing point. And the fastest wind here is actually a little slower than the South Pole. And we think the reason for that is that it's slightly more sheltered, the position here at the balcony. So the mountain is shielding the weather station a little bit from the high winds. I think if you go higher up, it gets even windier. So these are low temperatures, I mean, minus 45 degrees and a strong wind. If those things combine, it would feel really, really cold. And I can tell you that even during the spring expedition, when it was relatively warm, so when we put those weather stations in the balcony, I think it's about minus 20, minus 22 degrees Celsius, that sort of temperature. On the way up there, my hands have been cold a number of times, but we've all had cold hands before. What's different when you're at altitude is that your body is not as good at looking after itself with the cold because you're not generating as much heat inside your body because you're moving slower. There's not enough oxygen to power the metabolism. You're more prone to cold injury. So the image you see here are blisters that emerged at the end of my fingers, eventually emerged across all of my fingers. And it's the first stage, or one of the first stages of frostbite. It's very superficial, so no long-term damage. But essentially this was from having really cold hands up there during one of the warmer times of the year. So I can only imagine what it's like if you're up there in a winter storm. And it looks like, if you're up there in the middle of winter, according to some other estimates, exposed skin would freeze very, very quickly. So we're talking about, just a few minutes. This is the kind of damage it does in the spring. And it's when it's not that cold. So imagine what it's like in a winter storm. It's not a place you want to be. So what about the summit then? What's the weather like right at the very summit? Oxygen availability is even lower because the air pressure is lower, it's gone higher. So we think there the oxygen availability is about 33% of sea level value. And we're getting this, by the way, by looking at what's happening at the other elevations and then we call extrapolating to the summit. So we can see how things are changing as we go higher, and then we can work out what we should expect to the summit. That's easy to do with oxygen because it varies very predictably once we know that sort of height-oxygen relationship. Very straightforward to go up to the summit. With temperature, it's a little bit more tricky. So we're less certain what the conditions are like right at the summit. But our best guess at the moment, approximately, is the lowest temperature you should realistically expect to encounter on the summit is somewhere near minus 50 degrees Celsius. Highest temperature, we think somewhere around minus 5 degrees Celsius. But somewhere minus 5 to minus 10 would be my relatively broad but expert judgment as to where that highest temperature would fall. The fastest wind is the big question. I think it's at least 80 meters per second is what's realistic up there, so 180 miles per hour. But I would not be surprised if it were quite a bit higher than that. That's kind of I would say, a realistic lower estimate of what you could expect up there if you were to put a weather station, secure it in place, and if it lasted a long time. So we know a lot more about the weather up there now. Still don't quite know what's going right at the very tippy top, but we know what's going on for this huge elevational range from base camp to balcony. It's over 3,000 meters. It's over three vertical kilometers. So what's that, about almost 2 vertical miles? So it's a really great sample we've got there. We're now starting to understand a bit more about how sensitive the glaciers are there, the water resources to climate change. And if I made that seem easy, putting in the weather stations, it wasn't, and it was only made possible by this incredible Sherpa team. They were absolutely phenomenal. There's no way we'd put them in if it wasn't for their efforts. And you can see in this image, so Baker and I are in the middle. I'm the one with the glasses on with 2 hands up. Baker's as you're looking to my left with his finger raised pointing at the weather station. The rest of the guys there are just some of the Sherpa team. There are far more that were involved in this. They were just, I suppose, the last people standing next to the weather station when the image was taken. But they all did an incredible job. So the success of this, and overcoming that difficulty, entirely down to them. So I probably seeded a few questions there for the weather and what's it like up there, how does it feel, etc. So I'd be very happy now to answer those questions. So I'll stop sharing now, Joe, and pass back to you.
All right, Tom. Thank you so much. That was such a great presentation. What an extreme environment. I'm not surprised that some of those wind sensors might not still be giving those results back. So were you out in the field for the full 2 months of the expedition?
Approximately, yes. I mean, the in the field bit's quite broadly defined here, because you fly into Loughborough, which is at 2,800-ish meters. That's the closest you can fly to Everest on the southern side, on the Nepalese side, by plane. Then it's still a long walk from there. So it takes many days of you climbing slowly up to Everest Base Camp. And then we're probably at Everest Base Camp, I think, for around a month in total. So maybe a little more than that. So the time is split between sort of getting to base camp and then everything thereafter. But what I didn't mention here is we were doing some science along the way to base camp. There's one weather station installed quite a bit lower. So it was essentially 2 months of fieldwork related activity. Yeah, it was a great adventure. All
right, very cool. Well, let's start meeting some of our classrooms. So those tuning in via YouTube, you can use the chat bar, and I'll keep an eye out for your questions. For now, though, let's go to Minnesota. I'm going to bring in Miss Oakes in her 4th grade class. I believe they're joining her virtually. How you doing, Miss Oakes?
Great. Good morning. We have a question. We had lots of questions, but with the new weather data on Everest that hasn't been available apparently in the past, will that be used to perhaps give warnings to climbers or advisories on whether or not they should climb, and will climbers take that advice, or will they be forced to use that information?
Yeah, that's a really great question, and certainly one of the motivations of putting the weather stations in is that yes, they do open up the possibility for safer climbing, protection from the weather hazards, or rather, maybe a loose way of putting it, greater potential for warning of bad weather that's on the way. Because bad weather has contributed to around a quarter of the fatalities on Everest. So yes, we can improve the weather forecast on Everest with these stations. They're not currently being used in an operational sense for that. So the data aren't currently being used by any of the main forecasting agencies to improve their forecast. But that's just a matter of time, really. In principle, yes, we can do it. It's just we have to be. It now has to be operationalized, and that's a little takes a little more time to get all the pieces in place. But we've already learned enough to improve forecasting products.
All right, I'm going to bring in Mrs. Crowder's group. They're joining us in Kawartha Lake, so in Canada. I can see Miss Crowder's coming to the mute. Let's go. How you doing, Miss Crowder? All right.
We were really wondering if anyone had been hurt on the expedition.
Okay, good question. Yeah, it's a dangerous thing to do, to go and climb Everest. Our team, though, apart from my fingers and someone else's fingers that had similar blisters, there were no injuries. One of the youngest Sherpa, very strong climber, he may have had cerebral edema, which is essentially a serious altitude sickness that affects the head and can be very dangerous. So he had to go down quite quickly and get medical attention. So he got very sick from a high altitude problem, but no injuries. And actually, I think everyone on the expedition got sick. That's an unfortunate consequence of going on a big expedition to somewhere like Everest. Everyone's living in very close proximity to each other, and the immune system is not very strong up there because your body's working really hard to keep up with the altitude. So it means, common colds and things like that you can't fight off. And we had an outbreak of influenza in the camp as well. So we were sick many times, but nothing too serious. And beyond little cosmetic things on the fingers, no, there were no injuries. And one of our strong climbing Sherpa had an altitude sickness, but fully recovered and was okay.
All right. That's probably a combination, maybe a little bit of luck and really good planning. I'm sure there was lots of planning that went into the expedition.
There was fantastic planning, and National Geographic paid every attention to making sure that everyone was safe. And at no point was safety was always top priority, essentially. So I think it's no coincidence that there were no serious accidents with us.
All right, good stuff. So we've got Jo. Jo is hanging out at home. She's in Wisconsin. Let me bring Jo in. Hey, Jo, how are you?
Good.
Hi, Jo.
All right, Jo, you have a question for Tom?
Yeah, how many weather stations are there on Mount Everest?
That's a very good question. So there are 5 stations in total, but not all of them are actually on the mountain. So one is a bit lower. Otherwise, we have Base Camp, we have Camp 2, South Col, and then we have the balcony. So we have 4 that are actually on the mountain, and then 1 that's lower down in a place called Fort Say. And Fort Say, spelt with a P, is where most of our Sherpa team came from. So it's a famous village in the Khumbu region. The Khumbu region is on the way. Everest sits in the Khumbu region, and Fort Say is one of the most famous villages for climbing Sherpa. There are others, but that's where our Sherpa team came from, and it was a really nice spot for another weather station to get really long records of what's going on. Good question.
All right, I'm going to bring in Mrs. Oops, there we go. I'm going to bring in Miss Ruxton's class. They're a science crew hanging out with us. Let me bring them in live here. There they are. How are you doing?
Hi, we're just wondering if any animals live up where you were camped, or how high up animals live, or can birds even fly in that air? Kind of those kind of things.
Fantastic question. So there was a biology team that were part of the expedition that were trying to answer your question, essentially, trying to find out what lives up there. So firstly, the one thing I can answer very quickly with some confidence is that birds do fly at that altitude. And in fact, they can fly above Mount Everest. So I know from hearing another Nat Geo Explorer talk, actually, that the bar-headed goose can fly over Everest and does routinely. I think it migrates from somewhere on the Tibetan Plateau, which is to the north of Everest, down to the Indian subcontinent, so down to the south. So it flies over the Himalayas and over Everest in that journey. And I think, if I recall correctly, the first climbers of Everest, so Edmund Hillary and Tenzing Norgay, saw the bar-headed goose flying above them during their summit push. I may be wrong with that, but I've certainly heard the account that during a famous climb, the bar-headed goose was seen flying higher. So yes, you do find birds flying up there, and you see lots of birds, for example, at base camp, and the yak are at base camp. So you see quite a lot of animal activity at base camp. And let's not forget, base camp is 5,300 ish meters. So it's about 17,000 feet. So that's pretty high. There's been evidence, I think, of spiders found as high as Camp 2, which is 6,500 meters. So that's not far off 20,000 feet, is it? And the rest of or some other parts of the expedition are really trying to find out what could be living even higher, and looking for clues in the soil and the rock that's found up there. So we're very much I'm not, but other members of the team are very much working on that. It's a really intriguing question. So watch this space for more detail. But are things found up there? Yes. You get birds flying above the summit.
All right, very cool. Great question. Mrs. Dubreuil's classroom, there are some fifth graders joining us. How are we doing today? Oh, there they are. And let me bring that bigger for us so we can see them. There they are.
Yeah.
Oh, can you unmute?
Sorry. Yeah, sorry about that. We are joining you virtually, so I'm in the class and these guys are all at home. And we have a few questions. How fast do the glaciers move? Meters per second, if that's a possible measurement.
Great question. Yeah. I'll kick off with that one. So I think it moves at different speeds at different places, and through the icefall, it's like looking at a river. So we can use that comparison. When you look at a river, you notice there are fast flowing bits where it's narrower and shallower. You'll see it flowing faster, and then there are slow flowing bits where it's wider and deeper. And a glacier works exactly the same way. And the icefall bit that you saw us using the ladders to go through, that's like a waterfall on a river. It's moving much faster. And because it's really narrow there. I don't know if you notice in the pictures, you maybe can't see it, but it's much narrower there. So that ice has to squeeze through quickly. And there it's in the order of at least tens of meters per year. I think it may even be over 100 meters per year. It's certainly not in terms of thousands of meters per year, and it's not many hundreds. It's in tens to low hundreds, if I recall correctly. It moves different speeds in different places, and that icefall is the fast bit. You don't see it moving though, unless you see an avalanche or a block break off. That's how it moves, or partly reflects the movement.
But excellent, thank you. And then the other question I have to read. So have you been able to use the data collected by the weather stations to notice a change in the climate? And if it's too new, the device, tools that you're using, have you been able to compare it to previous data that has been collected? And then is this data that's collected going to be given to the Paris Summit Agreement countries and used to reduce their carbon footprint?
Well, these are fantastic questions. I'm blown away by their sophistication. So the first question: Can we deduce anything about climate change from these relatively short-lived weather stations? The answer is yes, in a couple of ways. Firstly, what we can do, as I think the question all pretty much worked out, we can tie that short-term record from these really high up spots that haven't been monitored for long before, to longer running data sets that aren't from there but are from nearby, and we can look at the relationship between the two, and that can be used to help extend the record from this new site that we're monitoring. So look at how they compare, and then use that longer running record to reconstruct, if you like, what's been going on higher up. Now there are some issues with that, some challenges, but that's what we have to overcome as researchers. But at least the potential is there to do it. The other way in which they give us some information about, let's say, the impact of climate change there is they tell us, by knowing what the current climate is like, which we can do now, they tell us how sensitive the snow and ice up there may be to warming. Because once we know how warm it is and how much energy or heat there is available to melt the ice, we then are in a good position to know what difference, let's say, 1 degree of warming will make, or 2 degrees of warming, etc. So yes, these are helping us already understand the impact, let's say, more generally of climate change up there. We have the better tools now to understand the changes that are ongoing. The second sort of block of topic was around the Paris climate change, or rather more generally climate change mitigation. And the next conference of parties will be in Glasgow. So generally, all this climate research that we're doing, that climate scientists do, does feed into the Intergovernmental Panel on Climate Change's reports on climate change. And that in turn feeds in and influences those discussions at the conference of parties. So yes, this science, all climate science, does have a pathway to impact, as it were. And essentially, the more visible the climate science is, the more likely that climate science is not going to fail to be noticed by those scientists that are compiling the latest evidence from different parts of the world. And let's just say this area, because it's so sparsely monitored, the acquisition of new data are disproportionately important. So I would hope that the findings from here do help contribute to the sort of the next round of material that feeds into our mitigation efforts. But they're fantastic questions. Was there another one that I missed?
I don't know if I asked it. I don't know if I got that far.
Mm-hmm.
Does it help with? Does it help using the renewable energy, like the solar panels, for the tools up there? And my class has mentioned too that solar panels aren't as reliable as other sources. Do you find the same? And they also want to know how you protect yourself when a weather event happens while you're climbing. But if other people have to answer.
Great question. I can answer, because I realized I missed out some details of how the stations work that I can cover now with this answer. So indeed, firstly, we get the data from them via satellite link, just like the explorers in Svalbard do. So that's how we have this continual transmission. That takes a lot of power, though, to pass the data out. So we do need those solar panels. And those solar panels, when they're clear, so not obstructed by anything, they provide enough power for the station to operate continuously. So they are charging the battery enough to keep that going. Over very long timescales, the batteries will start to degrade, but over the period that we've been using them for so far, we're not seeing any issues with that at all at the moment. So everything can operate sustainably in terms of power, or the power supply being enough to get the stations to put their data out. But does something obstruct the solar panels from time to time? Yes. What is that? It's snow. So during the monsoon, for example, which is the summer, it's also the warmest time on Everest, but that's when it snows most. So it's an unusual climate in that sense. That's what happens in the monsoon in the Himalayas. So during the monsoon, you get lots of snow, and that snow can fall on the solar panels, and it reduces the amount of sunshine that's available to those solar panels, and that can lead to the power dropping to a level where we can no longer send the data. And that has happened. That's happened several times. It happened this monsoon, so 2020, and also happened in the monsoon of 2019. But what happens is after a while, those stations, when the snow clears the solar panels, the sun starts to charge the batteries again, and then the stations come back to life. The other question about the weather, well, when we were up there, it was never too extreme, at least when we were climbing. It was never too extreme to not be protected with the equipment that we had with us, so the down suits that you saw us wearing. But really, the message here is prevention's better than cure. We were climbing during those conditions, relatively good conditions, because we were watching the forecasts and picking periods that looked safe from the forecasts. Of course, at that point, we didn't know how good the forecasts were because we didn't have measurements on the mountain, which is one reason those weather stations are now so important. But we were using the forecast to pick our moment. In the worst case, in a winter storm, the winds up there could be strong enough that they would blow you off the mountain. So essentially, if you're up against that, there's little you can do. You just don't want to be up against it. And there's no need to be up against it. The forecast are already probably good enough to just identify periods of potential danger and give them a very wide berth.
All right, great questions.
Yeah.
Let's bring in Miss Oakes and see if they have a follow-up. Hey, Miss Oakes.
Yeah, we have a couple of questions. We're wondering about the temperature on Everest. Is it possible with like global warming? Could it ever go above freezing at that altitude? And, could the snow melt? And then also a question about earthquakes. There are earthquakes somewhat as they fall in that region. Do they ever affect the Everest area?
Again, absolutely fantastic questions. So the melting one is really interesting because one, we're actually you can see from the numbers I showed you, we're not that far off reaching the melting, the air temperature going above the freezing point. And a sort of an unfortunate consequence of climate change is that higher up in the atmosphere, at least in the lower section of the atmosphere, for example, the aeroplanes flying, all the weather happens in, the higher you go up in that, generally speaking, the faster the warming is happening. So climate change goes faster at high altitude is one way to summarize that. So for a 2 degrees of global warming, for example, or 2 degree warming scenario, we would expect the top of Everest to warm more than that, and perhaps to reach around 4 degrees of warming. That sort of figure would be pretty reasonable approximation. And that puts us pretty close to the freezing point at the summit there. If I estimated that -5 to -10 is perhaps a plausible upper estimate of where we are right now, if it's -5, then we're very close to the melting point. But we actually don't need the temperatures to rise that much to see melting, because I think we're already seeing it up there. In fact, I'm sure we are at the South Pole, where we can be more confident what's going on, and it doesn't go above freezing there. What happens is there's enough sunshine, so much sunshine, that it's equivalent to standing on the edge of space. There's very little of the atmosphere to get in the way, and there's so many bright surfaces around there, snow and ice and low clouds. We get loads of interacting reflections, or rather repeated reflections of these surfaces. We have an enormous amount of sunshine, and sunshine heats things up. So the snow and ice can be melting because of that sunshine, even though the air above it is freezing. So another way to think about that, or to appreciate that, is we all know what it feels like when you accidentally step on a black asphalt pavement when it's been baked in by the sun. It's very painful to step on. It's much warmer than the air above it, and the same can happen with the snow and ice. Just because it's it's a cold surface, it can still be much warmer than the air above it. So snow or that sunlight can heat the snow and ice, bring it up to the melting point, and drive quite a bit of melting, even though the air temperature is freezing. So that was the first question. The second question, you should remind me, was another very good one, but I've temporarily gone blank.
Yeah, earthquakes. Do they
earthquakes
in that area? They
do, yes. And I always forget the year. I think it was 2015 or 14, the very big earthquake that hit Nepal. I think it was 15. And that did cause a lot of, across Nepal, it was really damaging. And it did affect the Everest region quite severely. It brought all climbing to a halt. I'm not sure, I don't want to mix up my histories, but I think it may have also caused a number of fatalities on the mountain. It's certainly a very impactful event. And the area is afflicted by those processes. And interestingly, those same types of processes, so let's say, because what an earthquake would do on Everest, or quite likely would do, and I think did, is trigger big avalanches. And interestingly, big avalanches do leave a signature in the weather that's recorded there. A big avalanche, an ice avalanche in the Dubreuil icefall, was recorded by a weather station several kilometers down the valley. So it picked up this wave of cold air and very dry air that was passing through, and that would come from this avalanche, pushing a whole load of air with it, a long way away. I mean, we're talking, it's tens of kilometers actually, I think, from the site of that weather station to where the ice fall or the ice block fell, or the ice avalanche occurred. And you could pick this up in the weather data. So it just gives you an idea of the scale of the forces that are at work there. And an earthquake is operating at it's very difficult to appreciate the amount of power that's released by an earthquake like that. But one way of sort of getting a small grasp of it is appreciating the enormous avalanches it triggers. So it's a dangerous location, all right, yeah.
All right, and one more trip to Miss Ruxton's group.
I'm a student. I just had a question. So, how long and how extreme is the training for like being able to reach the peak of Mount Everest?
Good. Yeah, good question. So it's a tough. It is a tough undertaking. So it takes obviously months of being out of climbing basically, or months of being at high altitude, and at least a couple of weeks of added together of proper high altitude mountaineering. So being at really extreme altitudes, going up and down, acclimatizing. So you do have to be in good shape to be able to do that. I mean, we trained, let's say, for probably a period of about 6 months, pretty intensely. So it would be in the order of something like 10 hours a week might be a reasonable number to pluck out the air of endurance training. So either running, cycling, hiking, those sorts of activities to build, really good general fitness, aerobic fitness. And then you also need to know enough about sort of operating in those cold environments, mountaineering, to keep yourself safe. So it takes a fair bit of preparation for sure. I mean, people do climb it with a lot less, so less fitness and less acquaintance with high altitude environments like that. And the fantastic Sherpa teams can get relatively inexperienced clients safely up and down the mountain, but it's just it's a more risky proposition doing it that way. But we all prepared very thoroughly for the challenge, because we also had to be working up there too.
All right. Well, I want to start out with a huge shout out to our YouTube crew who joined us. Thank you for sending in some of those great questions. A big shout out to all of our classrooms. Thank you for those awesome questions. That was really, really great. And then Tom, obviously, thank you for some time from your day.
You're welcome.
Your experience as we're kind of, talking about weather, extreme weather, and weather changes.
Yeah, and I want to thank everyone who listened. They are some of the best questions I've ever had. So yeah, fantastic. Well done, and thank you. And I do hope you find it interesting.
All right, amazing. Well, again, Tom, thank you so much. Big shout out. Enjoy the rest of your week, classrooms. You as well, Tom.
Thanks, Joe. Great to see you again.
All right. See you, everyone. Thanks so much for today.
Bye-bye.